Where's Norome? Can you text her?
She should be here soon.
Not the day before the test. It's kind of odd. Okay, copy on number 1, please. And then put your pencils down so we can talk about it. So it says, find the value of this sum, the sum. Okay. We went over this either yesterday or the day before yesterday. Okay. Think about it. Which are the only 2 series that we can actually find the sum of? Don't speak. Think about it. There are only 2 series, and we made a big deal out of it, that I can actually find the sum. Please don't forget, virtually all series we just determine convergence. There are only 2 series we can actually find the sum they converge to. Miss Mendoza, give me 1. Geo series I can find the sum. Mr. Torres, give me the second.
Telescoping.
The telescoping series. Is this a geo series? This should probably be a telescoping series. Now observe how a telescoping series is. Look at me. Now you guys may say, but Rama, this is not even close to being a telescoping series. Don't we need a factorable quadratic on the bottom? That's not there. No. If you think back to telescoping series, 2 steps down, after you do all that, I'm going to describe a telescoping series. Think about it and say, oh yeah, that's actually true. For telescoping series, do you not actually have monkey minus donkey plus orangutan minus panther plus and so on? So how could we do that here? Ms. Rios. Ms. Eunice. Mr. Ordaz. Thank you. Can you use the quotient rule for logs? 3 calculus I'm 3. So that guy is equivalent to summation 2 to infinity ln n minus ln n plus 1. Who remembers? Who remembers what we do next step? Once I have the 2 series. Plug in the values. Let's just plug in values. Should we plug in 2? Minus ln 3 plus ln 3 ln 4. Who remembers how many values we usually plug in? At least enough so that 2 of them cancel. Do you observe one of them cancelling if you're alert? So the next term will be, like obviously, you don't need to actually plug in, just look at the pattern. The next one will be ln 4 minus ln 5. Does that also collapse? So if you're alert to the patterns, put your pencils down. Is it basically telling you that terms ln 3 and beyond will all collapse basically? So what's your final answer? Not too bad. But you have to be alert. So it is not a technical, the way it is written, a telescoping series, like the way we think about it. But I can use a log rule of expansion, quotients, and then plug in values and the answer shows up. Okay, copy it on 2, please. Copy it on 2. So in the other class, the only fellow who guided me back on track, who told me how to do it correctly, was Mr. Pico. He's sitting in the back. Okay, otra vez. It says, find the value of. Okay, it says, find the value of. Therefore, I don't care about that now. Therefore, it's either a geo series or a telescoping series. Which one is that? Geo. It says 2 to infinity. Alright? So, what are the things we need to know for the sum of a geo series? The first term and R. What's the first term? How do we find the first term? What do we get? Okay, so the first term is 1 over sine 2. Unless some of you are directly going here. Okay, S to infinity. And then, what else do we need? How do we find R? Okay, careful. What is R? Nobody speaks. Look at it carefully. What is R really? Wrong. He says sine 2. 1 over sine 2. You're on the denominator. No. This is 1 over sine 2 to the power n. Can you say 1 to the power of anything is 1? Okay, now for those of you saying, why is it not sine 2? Look at me. I'll write a series where the common ratio is sine 2. But that's in the numerator. Okay? That is not the same as that. Obviously, they're not the same series. So, all over 1 minus 1 over sine 2. What? Oh, no. Oh, guys, you're correct. But we have stopped doing those problems like that. Guys, he says, remember, no, look at me. I understand these questions because Marshall asked me that question too. Remember that we used to do this problem, like we write this as sine 2 dot sine negative 1? Our formula is so robust, we don't have to do that anymore. As in ever again. Doing A and 1 minus R will take care of itself. It's already accounted for itself. You can do it, Mr. Manjan, but your answer will match. The formula is super robust. So those of you finished, what is the absolute final answer? Sine 2 over sine 2 minus 1? Yes? Okay, nobody did it correctly. Not one of you has done it correctly. Again, not one kid in this class has done it correctly. Okay, do you want to get ready to kick yourselves? Let me say this again. Not one of you in a class of 20, 25 students has done this correctly. The answer is the series diverges because 1 over sine 2 is greater than 1. That's a check that needs to be made. And we were mechanically doing the formula. Observe. It was there on your homework too, not this problem. But a divergent, how many of you remember there was a divergent geoseries? You're tempted to apply the formula and this is me kind of slapping your complacency up. No, that's not how the problem is done. Wake up. You need to make certain checks. Now you may say, how do I know that guy is greater than 1? Look at me. Sign of a number obviously lies between negative 1 and positive 1. So it's basically a decimal. 1 divided by a decimal. Will that become greater than 1? You don't even need a calculator for that. So the AP multiple choice was choice D, which is diverges. And I hope how you like the way I kind of just led you. Like sheep. Yeah, that's what we always do. It's going to be a killer. It's going to be a killer. You have to stop and pause and think. Because I have been assigning them for homework. If you're not checking your solutions, me and Ms. Masu discussed, like, did you recognize that was a divergent series? She said, yeah, this time I didn't, Rama. Because the first time you had it was day 109, assignment number 3, because I remember everything. So the human mind is not, it was there on yesterday's notes. How many of you read those notes, powerful notes, and you found it very easy to follow? I strongly recommend you read those notes. And one of the things against geoseries is this. It is very tempting to use the infinite formula without making the check that R is less than 1, if R is less than 1. One of the things on the notes, it's a caution. And this is me. Maybe some of you from now on will pause a little bit before you apply the formula. Now stop. I want to clarify. Now some of you will say, Rama, but most of the time we do it directly in class. What's going on? We never make those checks. No. Those are X problems. Where it says 1 over 1 minus X over 2 minus negative 1 over 1 minus X. Can you see that's a rational function? Are we talking about in the interval of convergence? You were okay. How many of you understand what I'm trying to get you? Can you see that these are not numbers? That's a function. So I don't need to check that R is less than 1. The question clearly says for X values within the interval of convergence. So we're okay. But if you have numbers, I have to pause and say, wait a second. Is the common ratio less than 1? Because it's very tempting to just race through the problem. And I wanted you to wake up. Okay, copy down 3. So can you please write down greater than 1, S infinity diverges. Sum does not exist. So please be a little humble. I've been assigning this for homework, and then finally I said, okay, I'll do this in class. And in the other class, Mr. Pico said, check that R is less than 1. And we talked about it. Nobody else, everybody was mechanically doing the formula. Okay. In your notebook, you can just copy this. You don't need to write tail, blah, blah, blah. Just copy that. And then write on the question, it says find one x-intercept and f double dash of negative 2. Okay, I'm using the word trigger, but not in the way teenagers are using it nowadays. Teenagers are using the word trigger as a synonym for any provocation, any source of annoyance. As in, mom says, take out the trash. Mom, oh my God, my mom is so triggering. Like, what? That's not how the word triggering is used. Okay, but I'm going to use the word trigger in its literal sense as in a cue, a signal. Like I'm going to trigger an idea, trigger a thought. Okay, who remembers when you see that kind of problem, Taylor polynomial, what does it trigger? Write the formula. If it doesn't trigger, you're looking at it, I have no idea. So let's write the formula in general. And the answer will just magically show up. So f of x equals f of negative 2, f dash of negative 2 over 1 factorial x plus 2 plus f double dash is negative 2. Negative 2 over 2 factorial x plus 2 square plus f triple dash of negative 2 over 3 factorial x plus 2 cube. And they ask a very weird question. They say, find an x-intercept. I have no idea what they're talking about, but usually what do we do next step? If my formula tells me this and those guys give me the series there, what do we do next step? Ms. Marquez? Thank you. She correctly says, match them up. So, compare them carefully. Therefore, f of negative 2 is 0. Is everybody okay there? There is no constant term. Stop! Can we answer the first question? What did it say? Find. So, no, look at your result. So what's your x-intercept? How many understand why that's the case? Isn't f of negative 2 0? Does that not make it the x-intercept? Connections. So the x-intercept was x equals negative 2. I don't know how the graph otherwise goes, but I do know one x-intercept is negative 2. But I hope you understood why. And then we can just answer the question. It says f double dash of negative 2. So which guys should I match up? What should I write in terms of work? F double dash of negative 2 over 2 factorial matches with negative 1, 6 signs. Okay, solve for f double dash of negative 2 yourselves. It's not a tricky question. So all of these kind of questions, just match them up, write the formula, match them up, and the answer shows up. Those of you finished? Is it negative 1/3? Just multiply both sides by 2. Negative 1/3. Okay, now put your pencils down. Let me discuss a tedious way to do the problem. The only reason I'm talking about it is this method will work. So there's a kid in the other class, I think Mr. Arnold. Mr. Arnold asked me, look at me, I hope you're paying attention. Mr. Arnold said, no, they want f double dash of negative 2. Rama, can I do the problem this way? I find f dash of x. Yes, doable. I find f double dash of x and plug in negative 2. Yeah, that'll totally work. Yeah, mathematically it's robust. They give you a series and they find f double dash. But is this faster rather than taking the derivative, second derivative and plugging it in? Just write the series, match them up, the answer will show up. Is that clear? Just cross multiply. Okay, copy note number 4, please. So we've been doing this in class for telescoping series, but the concept is a general concept. So it says the nth partial sum is given by that. So what is the question asking for in simpler language? Sorry? I love you, man. Guys, look at me. Can you see? Now, again, you need to be able to make connections between what we know and what's ours. It is fair game for them to use different notation. Okay, for the purpose of the recording, I need to copy down the question. So they gave us Sn equals negative 1 to the power of n, 3 plus 2 over n times n plus 1. Almost as if they did some telescoping series, blah, blah, blah. They simplified and that's what they got. Is that clear? That's what I'm telling you. That's the Sn. The question says find infinity. So he correctly, smartly says, yeah, we just need S infinity. So if you're paying even half attention, if I know that's Sn and I need S infinity, I just need to, sorry? Plug in what? Plug in 1. No, this is already done. We're already done. We have Sn. We don't have to plug in 1, 2, 3. Can you see there's no summation there? We don't have to plug in. Sorry? Take the infinite limit. Yeah, here's the concept. Look at your notes. S infinity is nothing but limit n approaching infinity Sn. Okay? It's there in your notes. We've been taking this down for a while now. Okay, take the infinite limit yourselves. Be a little humble. Don't be cocky and then tell me the final answer. Nobody speaks. You're taking the infinite limit. Be a little humble. Look at every term. Ms. Rios, take the infinite limit. What's your absolute final answer? Just use common sense. What's your best guess? Yeah, you're just taking the infinite limit for that expression. Ms. Noro?
Okay, I kind of have a question too. So, okay, I know it approaches 0, right?
Ms. Marquez? Diverges. It does not exist. Okay, explain to Norom why she was incorrect.
Because when you plug in infinity, the plus 2 over n, and that's 0.
So, no. That guy is 0. But we do have this term. Okay, continue, Marquez.
So when you plug in infinity into the -1, it's plus or minus 1.
From the first day of class. -1 to the power infinity is plus or minus 1. How many of you remember that? It can be a positive number or negative number depending on whether n is even or odd. So that, you're right, collapses to 0. But there is this guy. So that can be plus or minus 1 times 3. So plus or minus 3, which is not a finite limit. So Ms. Marcus correctly says diverges. So this guy was plus or minus 3. The answer is does not exist. Okay. That was a release question. Yes, please.
So is the final answer diverges or does not exist?
Same thing.
Okay.
The sum does not exist means diverges. Isn't that the definition of diverges? The sum does not exist. Sum is not finite. Okay. Copy down number 5, please. What were you thinking, Rios? Do you feel a little foolish? Because you knew it, didn't you? Okay, write on number 5, please. Okay, we have never discussed a problem like this before. So it says a third-degree Taylor polynomial for f has a relative max at x equals 3 in the first quadrant. Provide 2 reasons. I'll be honest though, this question came as a multiple choice. But the 2 reasons will talk about the concept so we can eliminate the choices, okay? I'm reframing it as if it's an FRQ. It wasn't an FRQ. It was a multiple choice question. So the question says, Ms. Dong, if you remind me, I'll send this document, yeah? So it says a third-degree polynomial has a relative max at x equals 3 in the first quadrant. Provide 2 reasons why T2 of x. Is that a typo? No, that is not a typo. That is a... Oh yeah, here's the typo. Isn't that supposed to be a second-degree polynomial? Why? So fix that. It's supposed to be a second-degree Taylor polynomial. So 2 plus 4 x minus 3 plus 2 x minus 3 squared. How do we always do these questions? I don't know where this is going, but what should we do? Write the formula perhaps, which is f of 3 plus f dash of 3 x minus 3 plus 2 x minus 3 squared. Oh, what am I doing? F double dash of 3 over 1 factorial plus f double dash of 3 over 2 factorial x minus 3. Okay, now stop. They're giving us some information. Okay. Yeah, to answer the kids' questions, yes, we know f of 3 equals 2, f dash of 3 equals 4, and f triple dash over 2 equals 2. Yeah, we get it. But that's not the question. The question says, why can that guy not be the polynomial? Let's read the instructions. They say it has a relative maxima of x equals 3 in the first quadrant. How might I want to use that information? What could I do to make it easy for me to process? What could I do? Like speculate. Like if you do this, then it's very easy to answer the question. Ms. Marzu? Okay. Fine. We'll go with what you're saying. So she says, look at f dash. What do you mean, Ms. Marzu? She's making connections. Like what is that being? What is the purpose of that? If it's a relative max from first semester, should f dash be 0? Is f dash 0? So that's one reason. Okay, I'm impressed, Mazu. So you have a relative max. The question gave you have a relative max. In other words, f dash of 3 should be 0. It is not 0. So that polynomial cannot be the polynomial we are interested in. Give me another reason. Give me another reason. Okay, go on.
And if it's a relative max.
Okay, guys, pay attention now. Okay, go on.
If it's a relative max, that means the second derivative would have to be concave down.
I love this girl. I'm very impressed. Nobody in the other class figured this out. So what's this? She's making connections. If it's a relative max, is the graph looking like this? Therefore, the shape is concave. Therefore, f double dash should be. And what do we have? Positive number. Very good. Can you give her a big hand, please? Because to be clear, here's the real reason we're giving her a big hand. Not because she answered the question. Because Mr. Psychosy didn't. It's a gag, Psychosy. He's taking it seriously. Okay, so guys, in the other class, I'm going to do something. The answer will just stare at the board, like obviously. So in the other class, we made a sketch. And the answer just shows up. It says relative max at x equals 3. Is it obvious? F dash should be 0, F double dash should be negative. The sketch makes it very apparent. So F dash should be 0 and F double dash should be 0. You can just then compare. Is that clear? So we were on the right track. We wrote the series. We compared them. But then you should use that information. And she was using that information. Like, if you have a relative max, what's going on? It should switch concavity. Not switch concavity. It's not a point of inflection. Just the fact that it should be concave down at that maximum. I'm accepting any questions. So I want you to process. Please understand, we have done a whole bunch of familiar questions. Now I'm getting closer and closer to mimic AP level questions. Like, yes, I'm forcing you to think harder. Okay, copy down 6, please. It says identify the series in terms of a known series. In simple language, all that means is either a cos x series, maybe an EX series, maybe a sin x series, maybe a tan inverse series. Guys, I'm giving you free reign. That's English. Free, not the precipitation. Free reign to speculate. I'm letting you know these are challenging problems. So feel free to say, why don't you do this? Maybe this will help us. Okay, so it says identify that series. What might I do to make my job easier? Okay, Mazu is not allowed to raise her hand. Somebody else. What might I do is it's easier for me to say, oh, isn't this kind of this? Again, let your imagination roam. If I did this, it makes my job super easy. Anyone? Because otherwise you're just looking at that and staring at it. Yes, Mr. Torres.
You plug in values?
Thank you! Can we plug in the values to expand? Look at me. When we identify series, are they already in expanded form? Then you can say, oh, that's sin x. How many of you understand what I'm trying to get at? They gave it to you in summation notation. We never deal with series in summation notation. He uses common sense. Why don't we plug in the value? Like, what could you do? Why don't we plug in the values and open this up and then see what's going on with the term? Let's do that. So can you please draw a skull next to your notes and write down expand the series? So the English word is expand. Again, I'm asking you to show some imagination. I don't have the answer to every single question. I want you to come up with, why don't you do this? Okay, should we start with one? Once again, guys, I want to show you efficiency. I'm speaking so to the board. You do not need to follow my instructions. Look at me. You do not need to follow my advice. But the kids who want to work a little faster and actually more accurately may want to follow my advice. Is it an alternating series? So I know the first term is negative. It'll flip around. Or positive, flip around, yes. Now look at that expression. What can you tell me all the powers are? Huh? They're all even. Very good. Look at me. For those of you who say, I don't know how even. Is that an even number? If you subtract it, will that be an even number? So in other words, here's what I'm trying to get at. If you have x2, will the next one be x4 and so on? I want you to be smarter and faster. Aren't these basically just successive numbers? And minus 1 factor 1, 2, 3, 4. I hope you get it. There's no pattern there. It's just a successive numbers. Now observe, I'm going to be fast. So I'll call it f of x, yeah? I'll call it, because it's a function. 1 minus 1? 0. So that's just... And then 2 times 1? Minus 2? So is that just 1 then? And then 1 minus 1, you're learning something new which I talked about in one of my emails. If you did not read my email, you lost out of it. What's 0 factorial? 1. Very good. That's 1. The first term is just 1. So that, now we'll be faster. So the second term must be a negative number. And then x, guys, we're looking at even powers. This had x0. That must be, if this was 0 factorial, what must this guy be? 1 factorial. What should this guy be? Next. Plus, over, minus, over. Do you observe the trick? Please be efficient. Plus, dot, dot, dot. Now put your pencils down. We have to do a little bit of thinking. Put your pencils down. If you are not memorized your series, it is going to hurt you tomorrow. Okay, look at the entire expression. Look at the entire expression. If you were to make a guess, which series is this guy closest to? No, look at all the terms. Don't be in a rush. Masharya looked at only one component and he said, is it this series? And wasn't even close. So if you look at the entire thing, which series would you make a guess? Louder? You can be more precise. He's going to the right track. He says, how about E? You can be more precise. Thank you. Is it E negative? You're right. But we were going to discover that. Now shut up. Okay, so is it obvious if you have memorized the E negative, all the, one of the powers, they flip-flop in negative signs, so you're going to write the E negative X series. And I'm asking you, it was there in yesterday's notes, I said memorize these 7 series. So it's really 1 minus, Miss Wynn already gave me the answer, or at least she came close. So 1 minus x plus x squared over 2 factorial minus x cubed over 3 factorial plus x4 over 4 factorial and so on. As a general rule of thumb, you want to write at least 4 or 5 terms. Because kids ask me, like, how many terms do I write? 3 is too few. I'm just letting you know, 3 is too few. 6 is too many. 4 and 5 are good terms. I would go with 5, but if you go with 4, most of the time you'll be okay. Now put your pencils down. Let's compare. Do the denominators match up? Do the numerators don't? Stop. Oh, by the way, let's be good habits. Equals E negative x. That's E negative x series. But if I replace x with x squared, will they match up then? So the absolute final answer is E negative x squared. I'm showing you, like the series is evolving. Okay, now stop. Let's have this discussion. If you were in a rush to identify the series, what series would you guess at? Cos, that's the numerator, not so fast. Which is why I said, because Masharya quickly said cos x. I said, no, Masharya, look at all the terms. So it's very seductive. Now there are even powers, and it flips also. But look at the denominators, not even close. So E negative, and then x squared. She rushed and said EX squared, because she could see the square term. But then observe the signs, please. So negative. Copy down 7, please. Copy down 7. Look at everything. And if you give up, ask yourself, what should it be? Nobody speaks. For the sake of the lecture, let me copy the series down. If you're not studying, it will. Yes, now shut up. Somebody whispered it, but not so loud. Remember, I have super sharp hearing. You're ruining it for the others. Miss Ryan. Here's how the 1 over 1 plus x series goes. It goes 1 minus x squared plus x cubed and so on. So if you pay close attention, 1 minus x squared, there are no coefficients. See, those guys are in the way. Those two guys are in the way. So the 1 over 1 plus x series do not have coefficients. Ms. Babar, Ms. Romero. Geo series. There is no formula that works. Now look at me. Some of you say, but Rama, Geo series works only for exponents. Look at me. There are exponents that you're not seeing. Look at the board. First of all, are these exponents kind of obvious? Now you may argue, but these guys, coefficients, Geo series don't have coefficients. No, we're okay. Because 25 is really 5 squared. 5, 1, 5, 0. There are exponents involved. So it's actually a geoseries. But guys, stop. Use my other trick. If none of the other ones work, it's a geoseries. Really, it works. Again, all the others have certain patterns. If you say, man, none of these patterns work, it's very likely geoseries. Now, don't get me wrong. I want to be clear and precise in what I say. Just because you don't see the pattern, don't say, okay, that's geoseries. Like in the previous problem, remember it was E negative S. Like, I can't see the pattern. Rama says then it's geoseries. It's all rubbish. No, to be clear, this did not follow any of the pattern of our established series. So it's a geoseries. So, what are the two things we find for a geoseries? So, just by staring at it, so we can write S infinity. Just by staring at it, what's the first term? 25 2/3 square. You don't need to simplify. And then 1 minus, do a sidebar, figure out the common ratio yourselves. Do it carefully. Okay, Miss Jung?
5.
Not 5. You're making 2 errors already.
Oh wait, no, 1/5.
Still 1 error.
Negative.
1/5. The signs flip. So negative 1/5.
2/3 cube.
2/3 cube. Thank you. Stop. We're doing geoseries with numbers. So if learning happened,
Oh,
check if R is less than 1. Okay, you don't rush and start doing the formula. I know, I'm tempting you by writing the stuff, but slow down. Okay, confirm if that common ratio is indeed less than 1. You don't need to think too hard. It'll be quite apparent. Because if you cube it, is that 8 over 27? And you have a 5 on the denominator. Is it fairly obvious? Is it less than 1? So all I'm trying to ask you is, please make that check. So the common ratio, absolute value, it was 8 over 5 times 27, absolute value, which is less than 1. So I can proceed. Okay, so as Ms. Jung said, is that negative 1/5, 2/3 cube. Everybody okay there? What's 2 square? Oh, sorry, what's 2/3 square?
4.
So is that 109ths? Where do you get 100 from? Times the 25 over 1 plus. And reread the notes I sent you yesterday. It said for GOCs, watch out for errors in R. So Ms. Jung made that error. She said positive. Okay. I said watch out, R can be negative, A can be negative. So watch out for the signs. Okay, plus 2 cube is 8. 3 cube is
27.
times 5, 135. I got it. Can we use a fraction trick? And this is the stage where I leave Miss Quinn alone and just say finish. It's not my job to show you simplification. You can just finish. Okay. We discussed this on Monday, Tuesday. Being a good teacher, we're coming back to the concept. I do not know if you were in class Psycho C, so pay closer attention. Copy down 8, please. We discussed this on Monday, I believe. So I'm spiraling. So the question says, with the aid of the 1 over radical K series, determine convergence of that series. My sinuses are acting up. I have a throat infection. And yet I showed up. Okay, it says determine convergence of this series. Nobody speaks. I want you to process mentally. Don't flip your notebooks. Process mentally. So here's my first question to the class. So which test do they want us to use? Nobody speaks. For that kind of thing, like we'll give you a series and see if that guy converges or diverges. Miss Hanson. DCT. Can you give her a big hand, please? So we're using a direct comparison test. So observe the logic. We went over this. Stop. We know that series, don't speak yet. I wanted you to process. We know that series, Mr. Dan, diverges. Can you give Miss Huyn and Miss Dong a big hand for tutoring him? I can't hear you guys. So stop. I want to see if you understand the DCT. We know this guy diverges. Therefore, that guy must automatically, if the test is being used, diverge. So I need to demonstrate that this guy is bigger than that guy. Is that clear? And then I hope you read the email that Ms. Writing texted me a question. And I said, that's an important question. Other kids may be confused too. So I just copied and pasted from my stupid text message thing and then emailed it to the entire class. It doesn't matter which one you write to the left or right. Okay, it'll work itself out. So my goal really is to demonstrate that that guy is bigger, right? So I'm going to... Okay. So we start with this. So I'm going to start with 1 over radical k. We're looking at a sequence. Now, we did not do this last time. I looked at the AP standards. They want a little more work. So I'm going to call this guy, say, Bn or An. It doesn't even matter. So An. Let's call this guy Bn. Now, observe the goal. My goal is to show that this guy is greater. Who remembers the shortcut that will demonstrate that it is greater? I'm going to cross multiply. Okay, that's my goal. I'm going to cross multiply. So is that k less than... Guys, I'm going to cross multiply. What's radical k times 1? Now careful. What's radical k times radical k? Plus k. What should I do next step? Subtract the k, like terms. Therefore, what's your left hand side really? Is greater than? Is that kind of obvious if k approaches infinity? Keep in mind k is the index. It approaches infinity. And that's true. Therefore, that guy must be true. This guy should be true. Now, what's the next step? What's the next step? Okay, I wasn't very formal in my explanation. I'm formalizing the explanation. So we know since, so write this down, since An is less than Bn, is it, we have to write, no, we're fine. Since An is less than Bn, is it obvious that summation An will be less than summation Bn? Yes, but summation An diverges by P series. Therefore, summation Bn diverges by DCT. I hope some of you find this easier, like once I call it A and Bn, I don't need to keep writing the series every single time. So I began with a sequence, look at me please. So that's, if you think about it, that's the, look at your DCT notes. We say An is less than Bn, how many of you remember that? We just say if An less than Bn, if Bn converges, then An converges, that sort of thing, right? So if you're going to say like that be An, it doesn't matter which one you call A and Bn. So please don't send me an email saying which one should I choose. It doesn't even matter. The order, I can write An there and Bn there. It doesn't matter. But we are more interested in demonstrating that that guy is bigger. It doesn't matter which way you write it. Ask me please. No, this work. All I'm trying to say is earlier we just did a bunch of algebra and moved on and rewrote. But the symbols or An and Bn is more like first we deal with the sequences and therefore then we deal with the series. Okay. Okay, copy that down. I've been assigning this for homework, but I'm not confident that everybody knows how to do it correctly every single time. So pretending to be a good teacher, I'm spiraling through the problem. Again, my goal is to do every single problem I can throw at you on the test at least twice. So, who remembers how we did that problem? No, Mazu, you're not allowed to raise your hand. Let's ask Mr. Huynh. If we break it up, okay, those of you are good at breakups, so you will find this easier to work with. Alright? So, I'm going to split up the series. So, can I write this as summation 4 over 6 to the power n plus 1? Okay, Mr. What's his name? Bunchen made the error in the second problem because I have a good memory. Let's see if he redeems himself now. Minus summation 2, 3 to the power n over 6 to the power n plus 1. Now put your pencils down please. I want to talk about this. Now when I began teaching GeoCs, I'm speaking to look at the board, Mr. Audash. When I began teaching GeoCs, this is how we did it. And I was telling you in that earlier problem, no, our GeoCs method about A1 and R is so robust, we'll be okay. So look at the board. Earlier we used to do this, Ms. Basu. Should we split out 6, 7, and 6? Pull it out. Can we pull out the 4? Pull out the 2? Can you write 6, 7, and 6? We don't have to do that ever again. No, never. Our A1 and R will take care of itself. Is that clear? So you don't make it hard on yourself. You can abandon that old method. That method works, but you don't need to use it. This is more efficient. Okay. It starts at 0 to infinity. So how do we find the first term? Okay. Plug it in, simplify, tell me your first term. Look down. What do we get? 2/3? Okay, 2/3 is not wrong, but there's a reason. I'm going to call it 4/6. Who can see ahead and think, raise your hand when you figure out 4, 6 is smart. Very smart. Miss One says, won't your denominator have a 6 on the bottom? I don't want to multiply the rest, I want to cross cancel. Okay, over 1 minus, okay, Banchan, what's your common ratio? Careful.
So I don't have to take up the 4?
Huh?
I don't have to take up the 4.
No. Guys, he says, what's with the 4? I don't care about the 4, it doesn't have an exponent.
Okay, so it's 4.
There you go, because earlier you said 6, remember the sine 2 problem.
Yeah.
Remember, it was sine on the bottom, you said sine of 2. No, it was in the denominator. So it was 1 over sine 2. So over here, guys, look at the board. He says, what's the deal with the 4? It does not have an exponent. It is immaterial to the common ratio. It's just 1 over 6. Is that clear? Okay, now let's do the other guy. Minus. Okay, it starts at 0. So figure out the first term. Same rules. Nothing has changed. This is far more efficient. Chorus? Is it 2, 6? Yes? Plus 0 over 0 is 1. 0 plus 1 is 1. 2 over 6. Over. Careful. Common ratio? Ms. Noron. Huh? 1/2 is correct. Look at the board, please. 2 is immaterial. 3n over 6n, like 3 over 6 is 1/2. Okay, can I actually leave it as 3/6? Okay. At this stage, I'm going to abandon you. Just not finish. I hope it's not a bad problem at all. Okay, this is nice, this is nice, this is nice, this is nice. Don't forget to take LCMs at the end. Just to make a note, LCMs at the last step. This is a multiple choice problem. That will not be the answer like monkey minus donkey. They'll want it simplified. Okay, let's move on. Okay. Okay, for those of you still a little iffy about maximum error. Okay, we're doing a maximum error problem. Oh, I'm going to scroll up. I'm just letting you know we learned maximum error on Friday first. So if you're still a little iffy, look at Friday's notes and then Monday's notes, Tuesday's notes. We've done maximum error every single day. It's also been assigned for homework. Again, Friday's notes were the best because there were 3 different problems. Okay, put your pencils down after you copy it, and let's talk about why this is a tricky problem. So, what's missing here? I'm letting you know. There's something missing here. What's missing? Remember, we're using the first 4 terms. So, we will operate on the 5th term. Exactly, we're operating on the 5th term. Alright? But there's something missing here. You'll be tempted to plug it in here, or what about deal with this? And it's wrong. We went over this yesterday and the day before. Anyone? Sorry? She says we don't have the series. Do you understand that's only the coefficient? How many of you understand that? Do you understand we are lacking the series? Let's write on the series formula. Okay? You could write in summation notation. That's okay. But all I'm trying to tell you is we're missing the series. Here's the series. F of x equals, how does that work? By the way, x equals 2. F of 2 plus f dash of 2 times, oh, no, this is not even relevant. Because that's not even the derivative, right? Can you see that's not even the derivative? Like, I can't plug it in. Okay, this is the series. We went over this the first day we did Taylor problem. See, this comes back. It's actually a0 plus a1, x minus 2. Who remembers that? Like, that is a general series. And look at me. So are those the coefficients? You get it? Those are the coefficients. Plus a2, x minus 2 squared. Plus a3, x minus 2 cubed. And so on. If you want, you can write down a few more terms. So you say, oh, I know what you are talking about. 2 to the power 4. And then a5 x minus 2 to the power. You don't really need to do all this. Okay? But I'm showing you that's what is really going on. And we are focused on the fifth term. Now observe this please. Here's how you get the first term. Look at me. We went over this when I talked about this weird series. For those of you not aware, have we not done the ratio test for this problem? Does that come back to you? We've done the ratio test for this problem. Okay. So I'm showing you how the series works, the term works. I'm speaking to the board. That's your first term. Is that clear? That's your second term. That's your third term. Everybody got the hang of the pattern. Alright? Now I'm interested in the fifth term. So I should be using how many of those guys? Should I be using 5 of those guys or 4 of those guys? Think. Chorus? 4 or 5? What should I be, how many terms should I be using? Ms. Romero? 5? But the first term will have a 0 in it. Can you see that? Okay, so that's the first term. That's the second term. That's the third term. The third term is this guy. Okay? Can you see for the third term we're plugging in 2. Does it matter? Or is it we just use 5? Because will the first term just be 2 over 2? Yes? So I believe we can just use 5 then, right? We just use 5. So now we're using the fifth term. We're using the fifth term. So it's 2 times 4 times 6. I don't need all the terms. I just use common sense. What's the next one going to be? And what's the next term going to be? 10. And then, guys, here's where most kids made errors. Isn't there an x minus 2 guy? What is x given to you, by the way? 1.8 minus 2 to the power of 5. Yes? All over. Look at the pattern. 2, 5, 8, 11, 14. Everybody okay there? Now, a small thing I've been telling Ms. Mazu to show the correct work. Now you're expected to cross cancel. Okay. 2 times 4 is 8. That collapses. 2 goes into 8 4 times. 2 goes into 4 twice. 2 goes into 14 7 times. So 2 times 6, 2 times 2, 4 times 6, 24 times 10, 240. 11 times 5, 55 times 7. 350, 35, 385. Oh, I can cancel the 5 and the 2 also, right? 10, twice. Okay, I can make it easier even. So 2 times 2, 4 times 2 is 8. No, there's a 6 there too. So 2 times 2, 4 times 2 is 8 times 6, 48. And then 11 times 7 is 77. Let me know if I'm making a mistake. And then what's 1.8 take away 2? As a fraction. 2 over 10. Let's not simplify. 2 over 10 to the power of 5. Is that 32 over 10 to the power of 5? Okay. I can simplify a little bit. Actually, 2 over 10 would have, 1 over 5 wouldn't have been bad. So 1 over 625 times 5. 5625? Yes, it's 5625. Okay. So you basically have to show that this guy is smaller than 1 over 1,000. In case you're saying, what is that 1 over 1,000? Oh, by the way, notation. We skipped the notation. Is the notation this? Absolute value. F of 1.8 minus F4 of 1.8. That's what we could do. Read the question again. What have we not done so far? Explain. Okay, it's been in your notes every single day. Nobody speaks. What's the explanation you're supposed to write? Like, why does this math make sense? Why could I use this math? What work do I show? Thank you. We're writing the explanation of the AST. So write down since. Oh, it is smart to do this. Call the series, basically, call the original series summation, negative 1 to the power of an an. So write it as an alternating series. The explanation is easier. So I'm calling the original series. Okay, so write down since negative 1 to the power of an an is alternating. Ms. Romero correctly says, okay, I need to do the alternating series thing. That's what you write for the explanation. Comma, what are the conditions for the alternating series test? An are positive. Okay, these guys, the coefficients are positive. So an are greater than 0. And then an are decreasing. You don't need to prove it. You just need to state it. An are decreasing. You look at it. Are these numbers getting larger and larger? Okay, by the way, just to be clear, for the kids who like to think, is this number clearly bigger than that number? So you're approaching 0. Okay, and it's decreasing. So a n are decreasing, and limit a n approaching infinity is 0. That's what you write for the explanation for the alternating series maximum error bound. Did you raise your hand?
Yeah, I think the 40.
Should we have 40 or 24? Okay, you just need to demonstrate that that is less than 1000. That's actually true. Okay, I can probably go higher. Okay, we're kind of running out of time. Copy down 11. We probably will not do 11. We'll just talk about it like couples. Okay, I just want to go over small things that students make errors on. Like, you don't do this, you don't make a mistake. You don't do this, you make a mistake. Right, Marshall? Okay. Okay, put your pencils down. We're not doing it. We'll just talk about it. So which series do we know? Okay, so observe. Don't write. Everybody, put your pencils down. We're just talking about it. When you copy the problem, what should you not forget to write in the next step? And that should appear in every step, guys. So x cubed minus 3x plus 3 parentheses tan inverse x. The question students will ask me is, how many terms should I write? Should I need to write the nth term? Not for these problems. It is okay if you write about 4 terms. Is that clear? Another thing, small things matter. Everybody, look at me. I do it. Some of you forget to do it. I don't know if Ms. Marzu does. Please don't forget to write plus dot dot dot. Remember, it's an infinite series. Don't just say first 3 terms or first 4 terms, parentheses. No, it's an infinite series. Write plus dot dot dot. Next, should you distribute the 3? If you think carefully, I'm using common sense. Very likely will these 2 terms collapse. I hope those of you who've done it now will say, yeah, that's going to happen. And then what do I do with every term? Divide by x5 carefully. What should I do in the very last step? Take the limit. So follow these instructions, copy it down. Don't do any sidebar stuff. Like, just copy it down the way it is. The answer will just magically show up. Just be attentive on the algebra. Yeah? Okay, last problem of the day. Copy down 12, please. Okay. I will be here after school creating the homework. So for those of you not aware, a bunch of kids, usually about 4 or 5 kids minimum, hang out here after school. I project the homework here as I work, and I'll be working downwards, and you guys can just hang around and work on the homework. Like every single day, there are a bunch of kids who hang out with me till 4:30, 5, whatever, till they finish the homework. You're welcome to join us if you want. Okay, and then put your pencils down. It says write the nth term of the series and find its value. Oh, by the way, if you want to make a guess of the pattern, look at the pattern. What do you first observe? It's an alternating series. So what should I start with? It says write an expression for the nth term. So -1 to the power n. Okay, I'm making sure students understand why they're doing what they're doing. Why is it not -1 to the power n plus 1? Nobody speaks. Why not n plus 1? For those of you who have never thought about it. Anyone? Thank you! You always plug in 0. If you plug in the 0, will the first term be odd? No, that's an even number. We always plug in. We have done the notes. Like the first term is always n equals 0. Write it down if you want to. Okay. And is that times 1? Obviously. Okay. If you look at the pattern for the first number, see if you can fill in the blanks here. Use common sense. Do not abandon your common sense. Look at the pattern. So what should the first number be? Ms. Rios. Here. 1, 3, 5, 7. You should be able to guess the pattern. In terms of n. In case you're wondering what I'm talking about. In terms of n. Mr. Javidi. N plus 2. It's 1, 3, 5, 7. If you say n plus 2, you mean you are talking just the natural numbers, but it's not the natural numbers. It's 1, 3, 5, 7. Ms. Huyn. 2n minus 1? Let's check. Javidi, can you see that odd numbers? So it has to be 2n plus or minus 1. Let's check 2n minus 1. You can speculate. What do we always plug in to see if it works? Will the 0 work? So we should make it plus 1. There you go. I'm showing you how to use common sense to figure it out. And then look at the next term and write it down. And the nth term should be 2 to the power of n plus 1, n minus 1. Plus 1, because we're plugging in 0. Did everybody understand the pattern, like how we figure out the nth term? Okay, we're not done. The question then says find its value. Okay, nobody in the class could figure this out. Look carefully about which series it reminds you of. Look very carefully. By the way, let's get this out of the way. It's not a geo series. It's 1, 3, 5. Kenny is not part of the geo series. So look at all the coefficients carefully and see, okay, which guy has that kind of thing. Mr. Psychosi? Oh, sorry, go on.
Would it be like 2n plus 1 as the exponent?
The exponent? Oh! Sorry. You're right. He says, aren't those odd powers? I don't know what I was thinking. Yeah. So, that's 2 to the power of 2n plus 1, correct? Thank you. The powers are odd, right? Okay, so which series does that guy remind you of? Think carefully. I'll give you a hint. The guy that repeats in powers, change that to an x. I'm giving you a huge, super powerful hint. So in other words, which is the guy that changes in powers? The 2? Replace the 2 or replace what with x? If you're clever. Ms. Baba, replace what with x? 1/2! That's very smart. Replace the 1/2 with x. Now see what the series is. So in other words, x over 1. Very smart, Baba. I'm impressed. X cube over 3. Now it's an easy series. Which series? Tan inverse. Very good. So rewrite it. I'm going to rewrite for you. Again, please study your series. So isn't the series actually, write this down, rewrite it. I'm rewriting it. I'm doing what Ms. Baba did in her head. Can you see? So they cleverly rewrote that 1/2 in a weird fashion. But if you think about it, that is nothing but the x minus x cube over 3 plus x5 over 5 without the factor is tan inverse. So that's tan inverse x with x being 1/2. So final answer, that. Guys, I want to know final words. Everybody, final words. If you can find that, I'm letting you know tan inverse 1/2 cannot be done by hand. 1 over radical 3 we can do. Radical 3 we can do. But actually it was in your homework yesterday. But you're not allowed to write your final answer as cos inverse 1/2, which you can do. You have to find it. You're BC students. So you will find tan inverse 1 over radical 3 to be pi over 6, tan inverse radical 3 to be pi over 3, tan inverse 1 to be pi over 4. I hope I'm making sense. If you can find that value, you must. You cannot leave it like this. But I'm making this clear. This one you cannot find by hand. So leave it alone. Thank you. And we are done with the final section of the final chapter of the final year of the final millennium of the fun. I'm kidding. This makes no sense after a while. Ms. Dong, you can pause the. Yeah. Guys. Shh. Let me be clear.